So we've left adding and subtracting until afterwards, and it's because it's not quite as straightforward. Well, I've said here, of course, this would be very simple with a calculator. If you haven't watched my previous video about how to use a calculator, make sure that you do. But without, how do we do this? Well, if the powers are the same, we just add the first numbers. Why is that? You might be thinking like, okay, well, it was a bit like multiplication. Let's just add these numbers and then we'll keep these parts the same. We need to think why that's true. So 4.3 times 10 to the 3, that's 4.3 times 10 to the 3. I'm going to move that decimal point 3 places. It's 4,300. And I'm adding to that one 2.1 times 10 to the 3, which is 2,100. So the reason you can just add those starting numbers is when you do 4,300 plus 2,100, all of the the decimal points would have been in the same place previously. So all the place value is lined up neatly. So all you need to do is just add up those parts separately, and you can just say that 4.3 and the 2.1 is 6.4, and you still have that same power of 10 to the 3, because when they have the same power, all of the numbers are lined up in the right column. If they had a slightly different power, let's say it had a extra power of 0, the 4 and the 2 would no longer be in the same column, so we couldn't just add them up together. Okay, so the answer for that one is 6.4 times 10 to the 3. If the powers are different, so if they're the same, you just add the first numbers together and check it's still in standard form. If the powers are different, there are two options. You can either convert them to ordinary numbers, like I did over here, and then you can add or subtract them, or you can force them to have matching powers by changing the one with the smaller power. So I'm going to show you both of these methods, and you can decide which one you prefer for the second section where it's your turn. So I'm going to do method one. Method one is changing them to ordinary numbers. Ordinary numbers. Okay, method one, 2 times 10 to the 5, that is 2 with 1, 2, 3, 4, 5 zeros. 3 times 10 to the 4 has got 1, 2, 3, 4 zeros. So when we add these together, we get 0, 0, 0, 0, 3, 2. So I need to put that into standard form. Well, that would be 2.3 times 10 to the power of 1, 2, 3, 4, 5. 2.3 times 10 to the 5. Now, method 2 that I would have, I'm going to force the one with the smaller power to have the same power as the other one. So that would be 2 times 10 to the 5. And then to make the other one have the same power, well, if I make that power 1 bigger, if I increase this power by 1, I'm actually timesing it by 10. So I need to divide that one by 10. And if I divide that one by 10, I get 0.3. So what I did there, I'm just going to quickly annotate that. I increased the power by 1, which meant that I needed to divide the 3. I needed to do the 3 divided by a 10 to get 0.3. Now that I've got them written like this, I can do the 2 and the 0.3 to get the 2.3, and I just keep the 10 to the power of 5 the same, so I get 2.3 times 10 to the power of 5. Okay, 4.1 times 10 to the 8. That would be 4, 1, followed by 7 zeros. 1, 2, 3, 4, 5, 6, 7. And then 3.2 times 10 to the 6. Well, there's going to be 5 zeros. 1, 2, 3, 4, 5 zeros. And then the 2 and the 3. So when I add these together, I'm going to get 0, 0, 0, 0, 0, 2, 3, 1, and 4. So in standard form, it's going to be 4.132. 1, 2, 3, 4, 5, 6, 7, 8 times 10 to the 8. Okay, so that's the answer for method 1. With method 2, I'm going to take the one with the smaller power, which is the second one, and I'm going to try and make it have the same power as the first one. So that would be times 10 to the 8. Now this time I've increased the power by 2, so the power has gone up by 2, which is the same thing as multiplying by 10 squared or multiplying by 100. So that means this number needs to divide by 100. The original 3.2 needs to divide by 100. And 3.2 divided by 100 is 0.032. So all I need to do now is add together the 4.1 and the 0.032, which gives you 4.132. If you do like a quick column method, 4.1 and 0.032, you very quickly see that you get 4.132. So it's 4.132, you keep the power the same as the second one, and you get times 10 to the power of 8. I'm just going to get rid of that to keep it a little bit neater. So this one, they have got different powers. So we're still going to do the first method of writing them in normal numbers. it would be 0.05 for the first one in standard form, and we're going to be subtracting something that has got 3 zeros, so it'll be 0.0021. So I'll fill in the gaps with zeros, I'll then do my subtraction. 5 becomes a 4 and carries to a 10. The 10 becomes a 9 and carries to a 10 over here. So 10 take away 1 is 9, 9 take away 2 is 7, and then I have 4 take away 0, and I have a 0 and a 0 here. So in standard form, it's going to be 4.79, and the decimal point has moved back 2 spaces, or there's 2 zeros, times 10 to the power of minus 2. Now the other method is whichever is the smallest power, I want to make it the same as the biggest power. Well, this is the smallest power because minus 3 is smaller than minus 2. So I'm going to keep the first number the same, which is going to be my 5 times 10 to the minus 2, and I'm going to be subtracting from it. I want the second one to have a power of minus 2. Well, this time the power has increased by just 1, meaning that the power has increased by 1, so I've actually multiplied it by 10, meaning I'm going to have to divide this one by 10. So I'm going to have to do 2.1 divided by 10, which is 0.21. So all I need to do is the 5 take away 0.21, and that is going to be 4.79. You think about doing, I don't know, like £5 take away 21p, you get £4.79. And then I'm just going to keep the power the same, so it's times 10 to the minus 2. So we get the same answer either way around for both of these. So you can decide which method you prefer. I probably prefer using, if the powers are small enough, this one feels a bit more reliable. If it's bigger, loads of zeros, you might like to use method 2. So pause the video and have a go at these 3 questions that we've got here. And I'm just going to pick maybe one method 1, and then I'll do 2 in method 2. Okay, so this first one I'm going to do using method 1. So this is going to be we'll have a 5 with 1, 2, 3, 4, 5, 6, 7 zeros, and then a 3 with 6 zeros. Okay, well there's going to be a lot of carrying and borrowing here, so you can kind of think that it's actually just going to be a 4, 7, 0, 0, 0, 0, 0, 0. Whatever this number is, what is it? 47 million. So we've got 50 million, take away 3 million is 47 million. It's probably quite easy to think of it as 47 million. And 47 million is 4.7 times 10 to the 1, 2, 3, 4, 5, 6, 7 times 10 to the 7. You could try method 2 for that as well. And I'm going to do method 2 for this one. So I'm going to force the one with the smaller power to match the other one's power. You'll notice I'm not that bothered about using brackets because of BIDMAS here. It's obvious that these are a pair and these are a pair. So the times 10 to the 4, the next one is going to have times 10 to the 4. So I've increased the power by 1, which means I've timesed it by 10. So I'm going to have to divide that by 10 to counterbalance it. When I divide it by 10, I get 0.34. So I just need to do 2.1 plus 0.34. That's just going to be 2.44. So it is 2.44 times 10 to the power of, not going to add the powers, times 10 to the power of 4, because it's still the same sort of size of number. And this one, with the one with the smaller power, we're going to try and make it match the other one. So this is the smaller power, so I'm going to try and make it match this one. It's going to be 3.82 times 10 to the minus 3. I want the next number, which is being subtracted to have a power of minus 3. It's increased from minus 4 to minus 3, so it's timesed by 10. So this is going to have to divide by 10, and you get 0.21. So all I need to do is my 3.82, take away my 0.21, 2 take away 1 is 1, 8 take away 2 is 6, 3 take away 0 is 3. So the answer is 3.61 times 10 to the power of minus 3. You keep that power the same. And of course, I'm just going to show you and remind you that you can do this all in your calculator. If I do 3.82 times 10 to the power of minus 3, subtract 2.1 times 10 to the power of minus 4, we do come up with 0.00361, which is equivalent to this answer that we have here. So that's all of the stuff you need to do with calculating. I hope that you do get used to using your calculator for this kind of stuff, particularly scientific mode that I talked about in the previous video. We're going to finish off here with doing some exam style questions. Some of them will be calculator and some of them will be non-calculator. Found this video helpful? Then why not drop it a like and consider subscribing to my channel. If you'd like the next video in the playlist, you can click here to be taken straight to it. And as always, wishing you the very best for all your studies.